listening into communication from the International Space Station. Very interesting project, very unconventional use of a sensor. So as you can see, when you think about sensors, we tend to think of it as something that is designed for a specific purpose in mind, with a specific application in mind. And what is happening today in IoT is that a lot of the data is coming from unconventional sensors in interesting ways and opening up wonderful new applications. The final example I had was Fitbit. Fitbit, I think, came around 2011, 2012. The Fitbit is a pedometer, right? And pedometer before Fitbit was very expensive. And the reason the Fitbit was not so expensive was that they reused the accelerometers from the Nintendo Wii. Again, a game console, right? It allowed you to move the wand and interact with the game. And they used that exact same accelerometer and reprogrammed it to become a pedometer, right? And suddenly they had a hit on their hands. I was one of the early buyers of Fitbit, and one of the biggest problems was that the step count was highly inaccurate. And it was not just a 5%, 10% error, right? I once wore it on a long drive to Chennai. I was in a car all the time, and by the end of that drive, it had counted some 15,000, 20,000 steps. It's basically didn't know that I was inside a car. It thought I was walking. And it was basically reading all the road vibrations and assuming that those were steps that I was taking. Now, it has gotten better over time, right? People have integrated more software. I think they kind of realize that you're in a moving vehicle and don't count steps when that happens. And accuracy today is not so much of a problem. In fact, when I was talking about it, people said, robustness, its ability to survive harsh conditions is a bigger concern today. But to me, the most heartwarming thing about this story was that, here's a company that took a sensor that was meant for a completely different application, packaged it into a nice little product for what is a semi-medical application, and in the process created an entire new product category. Right? Today it's not just Fitbit, it's Samsung, it's whoever else, right? It's a multi-million-dollar market that came out of unconventional use of sensors. So that kind of brings me to the end of my talk. There are a lot of things happening in IoT today, all manner of devices. The aspect that I wanted to communicate to you is about how IoT is unlocking access to unconventional sources of data, right? By using sensors in innovative ways and by looking at signal sources that we thought of more or less as noise. You bring this two together. In all cases, the data tends to be extremely dirty, unreliable, but it's not a trade-off. It really is the starting point for creating interesting new applications. So, thank you. So the code for this talk is all open source. If you're interested, you can write to me if you want to follow up. And I also want to plug our product. It's called zmode.io. Oh, sorry. So I put everything, including the presentation and the code. It's not very well written code. You can take a look at it. And this is our product. It's a home automation product that allows you to control devices from your phone through Wi-Fi. So, thank you again. Yeah. Oh yeah, tons of different apps are there. We have our own little twist. I'll be happy to talk to you about them. Ours is a so.
Like everyone is talking about IoT, but nowadays in market there are new concepts coming like IoT. So can you put a light on what is the base difference between IoT and IoT?
What is IIoT?
Industrial IoT.
Okay, so I think whenever new technology comes, and this is a story that I didn't say. So let's go back to the smartphone example, right? So when people know that smartphones are going to happen, when they think about who's going to use smartphones, the first thing they come up with is, oh, business users. It makes perfect sense for them, right? And to an extent that is true because they're going to be able to afford all the new technology. So the same thing is happening today in IoT, right? Industrial applications can afford the high price of very accurate sensors. So that is true. But over time, if you look at smartphones today, it's not a business device. It's a very mass market device, right? And similar thing will happen in IoT. And the steps that industrial IoT take will not necessarily impact consumer IoT. To me, looking at past history, the other way around is more likely. Consumer technology affecting what eventually gets implemented in industry is a far safer bet than the other way around. Yes, sir.
The code which you ran earlier, so that is processing. So generally image processing, when you talk about we have neural networks and everything.
Right.
It was not like were you running neural networks sort of thing, or it was simpler the way you broke the problem to 4 or 5 steps and then
Right.
coded to.
Right, yeah. It's just it's the technical name for it is color tracking. It sounds a little high funda. It's not. It's regular stuff.
So you were like temporal, you were comparing to images temporarily, like one per day.
Actually, you can do it even on a single image. You're just looking for patches that share the same color. So it's a type of object segmentation algorithm, right? It's often used as the first step to image processing. So suppose you want to do signboard recognition, right? And that involves neural networks, right? But the first step is find the signboard because you don't want to run your neural network on the entire image, right? And to do that, you just look for, okay, if your signboards are expected to be green, you look for patches of green in the image, right? So I basically use that one step.
So the neural network will even actually read what is it.
Yes, once you get it, you can then, because like I said, I mean, we have a lot of processing power today, but when you're dealing with HD images, the multiplying factor is huge, right? So it's very important to reduce the size of the problem with the first few steps and then do the subsequent processing.
So, Hari, my takeaway from this talk, essentially for any data scientist, would be firstly that there is going to be a lot of data that every data scientist is going to start working on, which is going to come out of IoT.
Yeah.
And secondly, the scale of this data is usually going to be fairly large.
Yeah.
And third, that this data is usually going to be messy. So data scientists need to be prepared for working with
Right,
messy data.
right. And it's messy in a different way. It's not messy in the sense that it's not, it's not adhering to a particular schema, not in that sense. It's messy in the sense that the very accuracy is suspect, and even the inaccuracy is not a bounded problem. It's not a 5% inaccuracy or a 10% inaccuracy. It's like, it's accurate or it's catastrophically inaccurate. Right, so, yes, sir.
Might be a very different question about the job. In the US, the farmers are using IoT to a lot more extent than that's been used in India.
Right.
So they use drones perfectly. They use the cameras on the drones, and they actually also do a lot of these. They actually predict as well, like which part of the crop has gone bad, where they can do a directed fertilizer or use the fertilizer. I don't see anything that's happening here. Is it like between the fact that we are treating our consumers only who are in the government sector? Or like how do you see that we have anything, how do you go about it?
I have thought about the problem, but okay, first of all, the two markets are different. I mean, you're looking at, in India, the agricultural sector is what, 30% of our economy or something like that, and it employs like 50% of the workforce, right? If you look at the US, I think it's much less, it's like less than 20% of the economy, and it employs less than 2 to 4% of the workforce. So their problem, their number one problem is human labor, right? So they're up against the wall.
That might be one of the cases very soon which India might be facing, because the fact that rural India has been like decreasing, like in the last 10 years, it's come down from 80% of what's 20 to 60% or something like that. People are like, there's a lot of brain drain or whatever it's called.
Right. So to the extent that you're pushed up against the wall and you're looking at cash crops, so there are people who are in India who are doing high-end agriculture, right? Hydroponics, who are trying to grow kale or cash crops or whatever, right? And those guys do invest in a lot of electronics, right? They do greenhouses, people who are growing roses, they do greenhouses, they do sensors. But that is a very, very small part of the agricultural landscape in India. Right? When you think agriculture, you're thinking of growing rice and sugarcane, right? And that, I guess nobody has yet found out a very good way to introduce technology there. When we talk to people on the agricultural side, I've seen a lot more interest in things like milling. Right? Mill owners do have pretty large operations and they do have specific problems that they want to solve. We heard about people spending lakhs of rupees for rice sorting machines, right? And we heard about it. It's an incredible piece of technology. You essentially have rice dropping off a conveyor belt, and there's a camera that looks at the rice, decides the size of that rice, and then activates a pneumatic tube to sort to blow air to sort the rice, right? And that stuff is being used in places like Chitradurga and Davangere in rice mills. So there are pockets of technology adoption, but yeah, it's very far from mass adoption.
So what do you think it will take? Is the question.
To me, it's about capital cost versus labor cost, right? Once you have, I mean, for the mill owner, his problem is he has a lot of sunk capital cost, and for him, he needs to keep throughput. It's all during the season. He needs to keep throughput, and he's willing to pay for that, right? The moment it's like you just need to hire more people, even if it's a little expensive, there is still a lot of headroom before you hit a insurmountable wall. I don't know.
Maybe one day we can probably solve the cargo issue.
We can use what I certainly hope so. Sorry, what is that? Recommendation. Yeah, good question. I think. Right. And so as I said, we are at a point where we are not yet able to foresee all the applications, right? And so as someone who kind of sees this technological trend, your best bet is to gain a very broad knowledge in the technologies driving IoT. That would be my answer to you, right? You may not actually work with these sensors. You may never actually design a circuit for these sensors or write code. But knowing the existence of it, knowing the sort of error rates, the sort of failure conditions, the sort of trade-offs, that is going to give you an edge in terms of when the field does develop and when the sensor data does hit, you probably will be in a better position to understand and deal with it if you take a very broad approach. And so, as I mentioned, we are developing an introductory course for IoT. And so when we thought about it, I mean, your choices are you can either make a bet on a particular technology, right? Or you can say, let's keep it very broad, right? Let's have a very wide-angle view of what's happening at a technological level. That provides a much better foundation for you to keep up with the field and adapt as it grows. Yes. So how the problem gets divvied up, how the different, how teams are split up. So for instance, now you have like app development, you have backend development, you have firmware development, and these are essentially different areas, right? People kind of think that they belong to one particular area. And what some of these IoT devices are doing is forcing these teams to come together. You cannot develop an app unless you know the device that you're dealing with. And while developing the app, you need to be able to debug the device also, right? And so that creates some amount of mix and match. And 3 years down the line, this is going to be resolved. People are going to find a way to slice the problem and subdivide it so that the amount of crosstalk between teams is reduced, right? But in that, first of all, you can't predict exactly on what lines it will be divided, and in the meantime, there is still a lot of opportunity to for professionals who are more broad-based.
I see some parallels with the analytics industry here. So 6 years ago, so I learned Jigsaw Academy. 6 years ago, when we were developing courses for analytics, again, it was the same situation. There were too many different things that we could have covered, and we came with a very broad course which would cover what we thought would be the broad, the most popular applications of analytics. Now, when we look at the industry, there are very, very specific roles for data scientists. So companies want business analysts, they want data scientists, they want machine learning experts, they want big data experts, they want data visualization experts. So now the curriculum is getting divided to align with these different roles. And I think something similar will happen in IoT as well, where right now we are going after a very, the most broadest, most popular applications of IoT, how we can cover those. And then over time, when there is more clarity within the world, then we will know what specific curriculum to develop for different streams.
One mistake.
Sorry.
We have many software simulation boards. We have boards and boards and Raspberry Pi is there. So do we have any simulations?
There are simulations for Arduino that you can find. They are not very well developed, but they are there. But yeah, there is still not something.
Not accurate as
It's not only about accuracy, it's also about number of sensors that are supported, right? So how much of it can you run? So yeah, it's still not very, very good. Sorry, sir, you had a question.
And words like telemetry, automation, instrumentation, sensors are not new.
Right.
Especially in manufacturing industry or heavy industry.
Absolutely.
How do you see the IoT coming there? Can we use the same set of sensors, same set of PLC and probably everything on top of it? Or you see a new set of intelligent sensors coming in and we need to probably adopt that and then do IoT on top?
So in the industrial context, the sensors that already exist, right? My sense is that they're not going to come down in price, right? But they are serving a particular need in the industry, they will continue to be used. So if I wanted to make a prediction on the industrial side, I would bet more on the connectivity angle. Because if you look at industrial automation, telemetry devices, one of the chief weaknesses, in my opinion, is that they use proprietary protocols to talk to one another. And there is very little interoperability. And people selling these equipments, they have very specific reasons for why they're using that particular bus or so forth. But when you think about it, right, the battle is already won. Today, TCP/IP, internet technology is what has won that battle, right? And so, as an industrial equipment vendor, the simplest thing you can do is get your device to talk to the internet. And the moment you do that, you're unlocking applications that can use data that you're collecting. More than the sensors itself, you basically can create an ecosystem in which people are, right? It's not just Siemens manufactures the sensors, they manufacture the connectivity, they give you the application, they give you the training. So it's an end-to-end provider, right? Once you break it up, it becomes more like the cell phone market, right? When there's somebody who's making the phone, there's somebody who's providing the operating system for it, there's somebody else giving the connectivity, and there are other people who are making the apps. It's a much more vibrant ecosystem can develop. At least that's my hope, and I think that's the low-hanging fruit on the industrial side, the connectivity angle. Yeah, well, not really a dashboard. It's more like you can think of it as a dashboard. It gives you controls for everything, but yeah. Okay, thank you so much. You've been a great audience.
Well, once again, welcome back, all the ladies and gentlemen. I'm sure you had great lunch. Enjoy? Yes or no? Yes. All right, so all geared up now for the last session. Well, ladies and gentlemen, for the last session, we have Mr. Rajiv Mukherjee, and the topic is going to be State of Analytics Talent in Indian Colleges. Mr. Rajiv Mukherjee is Senior Product Management and Marketing Executive who has 14+ years of experience in building, validating, launching, and marketing high-tech products in multi-billion-dollar companies like Ushamatru, Hidalgo, Person, and several startups in India. His current mission is to discover and nurture enterprising talent in emerging technology space in 800 plus colleges in India. A sought-after speaking at several conferences, proven leader in building and directing teams, excellent speaker, energetic, passionate, and customer focused. So ladies and gentlemen, let's put your hands together and please welcome Mr. Rajiv Mukherjee.